Hey everyone, and welcome. You ever stop and wonder, what's actually holding our digital world together? Well, spoiler alert, it's not magic. It's more like a fortress. And today, we're going to build one, right from the ground up, peeling back the layers on the invisible IT infrastructure that powers, well, everything. So let's dive into the blueprint. So let me ask you this. Where does the internet actually live? We all talk about the cloud, right? Like it's just this misty, floaty thing up in the sky, but it's not. The reality is the internet, all your data, every app you use, it all lives on actual physical hardware. And today, we're going to figure out what that hardware is and how it all fits together. So here's the game plan, our blueprint for today. First up, we're going to tackle the great data dilemma, figuring out where to put everything. Then we'll get to work building a data superhighway so we can get to that data in a flash. After that, we need to organize all the digital traffic. And finally, we'll post the network's bodyguards to defend our fortress. Right, so first things first, every single organization, I don't care if it's a tiny startup or a massive global company, they all face this one huge challenge. Data is just exploding, and it has to go somewhere safe, somewhere secure, and somewhere you can actually get to it. This isn't just a small detail. This is the absolute foundation of our entire digital fortress. You know, it really all boils down to something incredibly simple. Long before you're worried about huge databases or complex applications, you just have a file you need to save. Could be a document, a spreadsheet, a photo from your vacation. It's a problem we've all had. And that brings us to the ground floor of our fortress, Direct Attached Storage, or DAS for short. This is super simple. Think about the hard drive that's inside your computer right now or that USB drive you plug in. But here's the catch. The second you need to share that file with someone else, you hit a brick wall. It's just a one-to-one relationship. Okay, so this is where things get really interesting. This is our first major architectural choice. We've got our basic DAS, right? But then you have these two other big players, Network Attached Storage, or NAS, and a Storage Area Network, or SAN. And you can see the trade-offs right here. NAS is awesome for sharing files over a regular network. But a SAN is all about insane performance. But yeah, it's going to cost you more, and it's a lot more complex to manage. And this analogy just hits the nail on the head. So think of a NAS like a central library for the whole office. Everyone can go in, check out files, share documents, super accessible, super convenient. A SAN, though, that's a whole different beast. Imagine a private, super fast subway system that's built for one reason and one reason only, to zip raw data, what we call data blocks, between your most important servers and the storage. There's no casual conversation here, just pure, unadulterated speed. All right, so for the fortress we're building, performance is absolutely everything. We need that private subway, no question. The choice is pretty clear, right? We're building a storage area network, a SAN. Let's see what we need to build this thing. So what's in our SAN construction kit? Let's break it down. First up, you've got the host bus adapter, the HBA. This is basically a special card that slots into your servers. It's the on-ramp to our data superhighway. Next, the fiber channel switch. Now, this is not your typical network switch. This thing is a high-speed traffic director right at the heart of what we call the SAN fabric. And finally, the storage array itself. This is the big one. It's the high-tech, super secure vault where all the data actually lives. So how does this all work together? Well, it happens in a flash. A server needs some data. The HBA grabs that request and packages it up. The switch sees it and instantly routes it to the right storage vault. The array processes it, grabs the data, and sends it all the way back. And get this, that entire round trip, from request to data in hand, happens in microseconds. That's the kind of speed you need for the really heavy-duty applications. But wait. There's more. Even after you decide on a SAN, you've got another big choice to make. You've got Fiber Channel, which is the Ferrari. It's built from the ground up for nothing but speed, but it needs special hardware, special expertise. It's expensive. Then you've got IP SAN, which uses something called iSCSI. Think of this as the reliable family sedan. It just runs on the normal Ethernet network you probably already have, which makes it way cheaper and easier to deal with. But you're not going to get that Ferrari-level performance. Okay, so our foundation is rock solid, and our data superhighway is built. But now we have a new problem, traffic. It's starting to get crowded. You've got data from sales, from engineering, from finance, all flying around on the exact same network. It's time to bring some order to this chaos. We need to create some lanes, put up some traffic lights. Because right now, this is what our network feels like. Just one giant noisy room where everybody is shouting at once. Literally every device can hear all the traffic from every other device. It's noisy, it's slow, and honestly, from a security perspective, it's a complete nightmare. So, our first tool to fix this is the VLAN, a virtual local area network. What VLANs let us do is pretty cool. We can take one single physical network and basically slice it up into multiple separate virtual networks. It's like turning that one noisy room into a bunch of smaller, quiet conference rooms. The upsides are huge, as you can see. Way better security, better performance. But it's not a free lunch. If you mess up the configuration, it can cause big problems, and you definitely need smarter, more expensive hardware to pull it off. Okay, so we've organized the traffic. But now, how do we keep an eye on everything to make sure it's all running smoothly? Well, that's where SNMP comes in. It stands for Simple Network Management Protocol. Just think of it as a universal language that all our network devices can speak to report on their health. And this whole system really boils down to three key players, kind of like a team. First, you've got the manager. That's our central command center, the one asking all the questions. Then, on every single device, every switch, every router, you have an agent. That's the little piece of software that has all the answers. And finally, the MIB. The MIB is just a fancy name for a dictionary. It tells the manager exactly what questions it's allowed to ask each device. So a normal conversation is pretty simple. The manager just asks an agent, "Hey, how are you doing?" But the really cool part is something called a trap. See, if a device runs into trouble, say a connection suddenly drops, the agent doesn't just sit there and wait to be asked. It proactively sends an alert, a trap, straight to the manager. That lets the network admins jump on a problem before anyone even knows it happened. All right, our fortress is built, the city inside is organized, traffic is flowing smoothly, but a fortress is pretty useless without walls and guards, right? So it's time for the final and maybe the most critical step of all, defending this thing. And our first line of defense, our front door security, is the firewall. Honestly, the bouncer analogy is perfect. The firewall stands at the door between our safe internal network and the wild, untrusted internet outside. It checks the ID of every single piece of data trying to get in or out. And just like real-world security, firewalls have evolved a ton over the years. The first ones were simple packet filters. They just checked your basic ID. Then we got stateful firewalls, which were smarter. They could remember who was already inside the club. Proxy firewalls act like a personal escort for your traffic. And today we have next-generation firewalls. These things are like a full-blown, high-tech security team with advanced surveillance, threat intelligence, the whole shebang. Okay, two other bodyguards you hear about all the time are VPNs and proxies. And people get these confused, so let's clear it up. A VPN, that creates a totally private encrypted tunnel for all of your internet traffic. It's perfect for someone working from home who needs secure access back to the fortress. A proxy is different. It's more like an anonymous middleman for one specific request, like browsing a website. It hides who you are, but it doesn't necessarily encrypt everything. Bottom line, they are very different tools for very different jobs. And just like that, our digital fortress is complete. Let's recap. We started with the massive problem of data storage, and we decided on a high-performance SAN. We built out that superhighway with our fiber channel switches and HBAs. Then we brought order to the chaos with VLANs and put our monitoring system, SNMP, in place. And to finish it off, we deployed our bodyguards, our firewalls and VPNs. So, I guess the big takeaway is this. None of what we talked about today is magic. It's a masterpiece of engineering, a carefully designed system where every single piece has a crucial role to play in giving us the performance, the organization, and the defense that our digital world absolutely depends on. So yeah, we've built an incredible fortress. It's ready for today's data. But here's the thing. The amount of data we're all creating is growing at an insane pace. It's not a stream anymore. It's becoming a flood. So the question to leave you with is, what happens next? How does this fortress have to evolve? What do we do when today's data superhighway turns into tomorrow's gridlock traffic jam? That is the next great challenge. Thanks for joining me.